This video functions as an addendum to the existing Billiards Everything tutorial on YouTube. Specifically, this video is going to discuss a feature called AutoPolyVary. It assumes some familiarity with the existing Billiards Everything application because AutoPolyVary builds upon the functionality of PolyVary. Specifically, PolyVary is able to fire code sequences at an existing view on the screen, whereas AutoPolyVary is given a list of holes to fill, and then it will set the screen's view to each one of these holes, and then fire shots from an algorithm very similar to PolyVary at these views. So I'm going to go ahead and start up the Billiards Everything application. I'm running the jar manually through the Windows subsystem for Linux, but in most cases, you'll probably just be running a jar specific to your operating system. So let's go ahead and do that. And then a database window appears, a database selection window appears, and I'm just going to choose a demonstration database that I've made for the purpose of this video. And when I do that, it loads the Billiards Everything application, as you can see. So I'll choose to reflect this and load up a cover that I have prepared earlier. As you can see, it's incredibly simple. There are very few code sequences overall, and we'll just calculate the MRR regions and see what happens. Now, I'm using the standard 22 decimal places in the output, and I'm using 18 subdivisions. For a cover like this, this is a bit overkill. However, I sort of want to demonstrate what AutoPolyVary looks like in the event that you run it on a use case, I guess similar to the ones that you'll probably be using it for. So we're also going to generate 10 holes, just so that we can demonstrate the way that AutoPolyVary goes through the holes, but not on too many of them. In most use cases, you'll want to probably use about 100 holes. I know 100 is the number that I choose most of the time. So with that in mind, we'll calculate our MRR region, and we'll see the output appear on the terminal. Okay, so that's all done now, and let's just magnify and see our MRR region and what it looks like. And we can also see the list of holes that was generated for us by the calculate utility. So what we're going to do is put all of these in a file. So to do that, I'll just copy the list of holes as given in the output from the calculate function, and then I will save them to a text file. So new text document. I'm going to be fairly uncreative and call it holes.txt. Then we put the holes in the file, save the file, and with that all done, we can close Notepad. Now, to load our 1x1 file, we click the button that says Load 1x1 file. And now I select my holes file, and that's loaded. The viewer will automatically jump to the first hole in the file. In this case, it's the one given by the coordinates approximately 561, which you can see is more or less the center of my screen at the moment. Now, what we're going to do is give these holes to AutoPolyVary, but before we do that, it's worth doing a quick recap on what the boxes that I'm circling with my mouse essentially represent. So note for each code sequence that we're given, following the type of code sequence that we're dealing with, a pair of two integers. Now, these integers both represent things to do with the actual sequence of numbers that the code sequence, I guess, is represented by. So in this case, with the OSO that we've got at the very top, the numbers are 5 and 43. The first number, the 5, represents the number of integers following, well, the number of integers describing the code sequence, and the 43 represents their sum. In the same vein, for the OSNO down here, we have 14 integers, and they sum to 86. And feel free to pause the video and verify that. The boxes here, next to this blue vary button, represent the constraints on the sum of the integers in each code sequence that we search for. So the 0 to 200 essentially means that, well, every code in this list passes because all of these integers are between 0 and 200. We also have next to the AutoPolyVary button a start and an end box. Now, in our holes.txt file, we have 10 lines of holes, and this start line and this end line essentially represent the line of the file to start at and the line of the file to end at, in terms of essentially a way of specifying a range of holes to run the AutoPolyVary algorithm on. If you leave both of these boxes blank, then AutoPolyVary will run on the whole file. For the sake of argument, though, I'm going to do the equivalent of leaving the boxes blank and just put the entire range of lines in the file. Also note that it's one indexed. With this in mind, I can now click the AutoPolyVary button, although actually let me increase the sum constraint, and we'll also just search for CS sequences, and while I'm at it, I will change the colors to red and blue. When we press the AutoPolyVary button, we get a few options. Firstly, we have to verify that the polygon in here aligns with the one in our cover window. As we can see, it does, so that's good. And then we get more options below the polygon input section. Specifically, all of these CSMax, OSOMax, and OSNOMax boxes represent the constraint on the length of the sequence that we search for. So just recall that this 500 represents the side sum of the sequence we search for, but these represent the length. Now, in our case, let's just arbitrarily say we'll impose a length of 200 on our CS codes, and the OSNO and the OSO codes do not matter because we've already deselected them from the types of code sequences that we're going to find. Now, we're ready to press the AutoVary button. And when we do this, a box appears telling us the line of the file that's currently being worked on, and you can see the viewer jumping and filling the screen with all of these new codes that it's finding automatically. And now we're done. So if I scroll down on my terminal window, you will now see that we are told the constraints that we ran AutoPolyVary with, and we are given a list of all of the code sequences which it found, which we are now able to copy and put in our cover. Now, the use of AutoPolyVary is that if you have a lot of holes that you want to fill, sometimes it can be incredibly arduous to run PolyVary individually on each of them. So what you can do is generate a list of holes from the cover window, put them in a text file, load the text file, and then run AutoPolyVary on it.